Hello, everyone. It's Mr. Kissinger at the Citizenship Academy in Syracuse, New York, and this is 5th grade math module 5, lesson 2. Today we're going to be finding the volume of right rectangular prisms by packing with cubic units and counting. So we're going to be making a rectangular prism out of cubes, and we are going to be packing them with cubic units to find out how many cubic units will fit inside of that prism. And I'll show you what I'm talking about here in a second. So here it's asking us is make the following boxes on centimeter grid paper. Cut and fold each to make 3 open boxes, taping them so they hold their shapes. How many cubes would fill each box? And explain how you found the number. So I didn't make all of these. I just made just the one here. So I have this letter B. So we're going to be doing this letter B here. And as you see, I have the bottom of my shape here is 3 by 2. I have 6 square centimeters on the bottom there. But this is going to be 3-dimensional, so we're going to make it not square centimeters, but cubic centimeters. So if I fold this shape into a box like that, now I have a rectangular prism, a 3-dimensional rectangle here. And on the bottom, as you see, I have 6. 1, 2, 3, 4, 5, 6. And I have 6 cubes on my first floor of my little building here. So if this was a building and I had 2 floors, my first floor would have 6, but it has 2 floors. So I have 6 on the bottom, and if I packed little cubic centimeters into here, I could fit 6, and I could fit 6 more on top of those 6 to make my second floor. So out of 6 plus 6 would be 12 cubic centimeters. So I have 12 cubes. All right. So seeing that visual model just like that, we can picture what it would be like if we made this letter A into a folded up cubic structure there. We have 4 cubes on the bottom, and it looks like this way in every direction. We only have 1 floor of our building this time. So we have 4 cubic centimeters, and that's it. We don't have another floor to count. So this is going to take 4 cubes. And then letter C, we have 1, 2, 3 by 1, 2, 3, 4. So we have 12 across the bottom here. And it looks like in every direction we have 2 floors. When we fold those up, we're going to end up with 2 stacks of 12. So we're going to have 24 cubes altogether, or 24 cubic centimeters. Next here, it says how many centimeter cubes would fit inside each box. Explain your answer using words and diagrams on each box. So we look at the top of here, it is open, so we would be able to pack centimeter cubes inside of that box. And it looks like we have 1, 2, 3, then we have 4. But back here on the back of our box, we could also fit 2 more cubes. So we have like 5 and 6 back here. And we'd be able to see that if this was a block, we'd be able to see all 6 of those. But because it's a box, we're just seeing the back side of that box. So we have 6 cubes that could fit inside that box altogether. We just have 1 floor, and we have 3 by 2. So we have 6 cubes. And we have 2 rows of 3 cubes. In letter B, we have 1, 2, 3, 4, 5, 6. And then back here, it looks like we have 2 layers. So we have 1 layer of 6 here, and then we have 2 layers of 6 there. So if we have 2 layers of 6 cubes, that's going to give us 12 cubes. 2 layers of 6 cubes. All right, and now on this one, so it looks like we're going to have 2 layers again, because this box goes back 2 squares or 2 cubes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 2 layers of 16 cubes. This is going to give us 32 cubes altogether. All right, 2 layers of 16 cubes. And number 3, it says the box pattern below holds 24 1 centimeter cubes. Draw 2 different box patterns that would hold the same number of cubes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then there's 2 in every direction here coming off of our box. So we have 2 layers of 12. Another way that we could draw that to make 24 centimeter cubes fit inside of the box is we could do, well, let's do, 6 times 4 is 24. So we could do 4 layers of 6. So if I add 6 on the bottom, we add, let's make it 3 and 3, just like this. Gotta make it a little bit bigger than that. I'm really dropping the ball on this drawing here. All right, it's gonna be like kind of right in the middle of the 2 that I drew, right there. Perfect. All right, so we have that, and then we're gonna go up 4. I'm gonna shade these in so we know this is the bottom of our box. Up 4. This way 4. That way 4. And this way 4. Oh, that's only 2. Keep going. I'm gonna go over our words a little bit. It's all right. We need the space. A little bit big. We're gonna borrow some space down here as well. This is gonna be a really big box. Oh, that was pretty ugly. This one the same size as the other ones. All right. We get the idea. So we'd have 4 in every direction, and we have about the bottom of our box at 6. That'd be a box that has really big sides on it. And then we'll make a smaller one over here. Let's do, so 24, let's do a bottom of 8. So we'll do 1, 2, 4. Those are super square, so I'm going to make them a little bit smaller here. Remember, we want them to be square. So when we make all the sides to it, it'll be a cube. We want them to be somewhat close. All right. So they're square, just about. And we're going to have 3 going each direction. So if I make 3 here, I'm going to shade in this part here so we know this is the bottom. We're going to go 3 in this direction. We're going to go 3 in this direction. We're going to go 3 in this direction. All right, and then we have a box that has 8 stacks of 3, or 3 stacks of 8. So we can set 8 cubes, 3 layers, or 3 floors high. That's a little bit tough without graph paper. But the idea we want to get is that when we stack cubes inside of these boxes, we have 6 cubes. Well, that's 6 cubic centimeters because we have each one of those, or cubic units. In this case, it's not necessarily centimeters, it's units. So that's all the time we have for today. Thank you guys so much for tuning in, and I look forward to seeing you next time.